Hi everyone, welcome to iQuanta. I am Yogesh and welcome to the 10th session of 250 most important, most expected questions for IPMAT Indore. Okay, today's session is going to be slightly inclined towards PNC. We will be doing some integral solution type of questions which can come in the exam. Okay, I gave you two questions as homework. I hope you attempted them. If you are attempting IPMAT 2026 and you are looking for a crash course which is very rigorous for 45 days and prepares you for IPMAT Indore, Rohtak, jipmat with rigorous revision, then you can join this course. Okay, we are starting from 29th of March. You can visit iQuanta.in/IPMAT to enroll for the course. There are discounts as well. Okay, so those who want discount, they can comment below. I will give them the coupon code. Okay. If you talk about the playlist section of this channel, you will be getting a lot of playlists. Okay, if you want to increase your practice, variety of questions, you can go to quant playlist, you can go to numbers playlist, you can go to idiom phrases playlist, vocabulary playlist. There are so many playlists over here. Okay, and if you have not done data interpretation, there is a playlist here, has 50 plus sets and will cover good amount of your data interpretation sets for IPMAT Indore. Okay, I give you this particular question as homework. I hope you attempted them. An article is marked X% above the cost price. So you know that when you increase cost price by some amount, that is called mark price, isn't it? So you marked up the CP by X%, a discount of 2x by 3% is given on the mark price. So when you give discount on mark price, it becomes the selling price. If the profit is 4% of the cost price and the value of X lies between 25 and 50, then the value of 50% of X is. So here now the profit is 4%. So when CP is increased by profit, okay, if you add profit to CP, it becomes SP. So in this process as well, if P is my cost price, okay, I increase it by X%, okay, this becomes what? This is MP. On MP you give a discount of 2x by 3, so it becomes 1 minus 2x by 300, right, 2x by 3 into 100, that is this. This is what? This is actually your SP and you have been given that there is 4% profit. If you add profit to CP, it becomes SP. So that means if you multiply CP, that was P, by, you have to increase something by 4%, you will multiply it with 1.04. This is what you will get, isn't it? PP cancels, what do you get? If you take LCM over here, you will get 100 plus x upon 100, then you will be getting 300 minus 2x upon 300, and over here you will get 1.04, right? Understood? 1.04 can further be written as 104 upon 100, right? Two zeros will be cancelled, you get 300 here, 300 into 104 is 31200, right? So this is 31200 over here. Here if you do it, you get 300 and 00, 100 and 300, you get minus 2x square, and then you get minus 200x plus 300x, that means plus, okay, minus 200 plus 300, so 100x, isn't it? This is what you get. This becomes 2x square, goes that side, then minus 100x, and then this 30,000 and 31,200 minus 30,000 becomes plus 1200. This is equal to 0. If you solve it further, you take 2 common, what do you get? X square minus 50x plus 600, that is equal to 0. You just have to factorize this. This is 20, 30, okay. So x minus 20, x minus 30, that is equal to 0. X has two values, 20 and 30. Which one will you accept? X lies between 25, 50. So you will discard this value 20. That means this is your value of x. You wanted 50% of x, that means half of 30. Half of 30 will be 15%. That's your answer for this question. Okay. Do you have 15? Yes. That's your answer. Okay. So this is a very easy question, not very difficult one. Okay. Next question is, let P be the point of intersection of lines this and this. There are two straight lines, they will be intersecting, maybe something like this. Okay. This will be their point of intersection and this point is P. Okay. Q is the point of intersection of lines 3x plus 4y equal to 2018 and 5x plus 3y equal to this. So say these are two lines which are intersecting and this will be Q. Okay. So these two lines, this is the intersection, those two lines, this is the intersection. If the line through P and Q has slope 2, line through P and Q, that means this is your line, it has a slope 2. You know what slope is, right? If there are 2 points, okay, one has coordinates x1, y1, okay, another has coordinates x2, y2, then what is slope? Slope is denoted by m, right? slope is y2 minus y1 upon x2 minus x1, okay. So, you basically have to get the intersection points, you know how to get intersection points, you solve these two equations, you will get intersection point, okay, find out the value of x and y. So, you have this, okay, I'll show you how to find out the intersection point of one line, you can find out the intersection point of another, and then the intersection points here will be x1, y1, these two intersection points will be x2, y2, then you can apply the slope formula, put it equal to 2, okay, because slope is given 2. So, here you have 3x plus 4y and that is given equal to 2a, and here you have 7x plus 2y. 7x plus 2y, you have to cancel either x or y to find out the value of x and y. So, if this is 4y here and I want to make this 4y here, so I will multiply this entire equation by 2, it becomes 14x plus 4y, 2018 into 2, that becomes 4036. You subtract this from this, what do you get? You will get 11x equal to 4036 minus 2a, x will be 4036 minus 2a upon 11, right. You have got the value of x, that means the x coordinate of this intersection point is 4036 minus 2a upon 11, right. And similarly, you got the value of x, you can put the value of x over here, right. You will be getting what? The value of y, isn't it? If you put x over here, you will be getting the value of y, so you will get the intersection point, okay. So, there will be another intersection point over here, and this point will be called x1 comma y1, okay. This is x1, this is y1. Similarly, can you solve these two equations, eliminate x or y in the beginning, you will be getting an intersection point over here. This will be the value of x2, y2, there will be two intersection points, right. Now, you have to find out the slope, slope is given 2, 2 will be written as whatever value of y comes here, y2 minus y1, okay, this value, and then upon x2 minus x1, if you put it over here, y2 minus y1 upon x2 minus x1, you can solve it and you will be getting the value of a, okay, and you can match the options. This question is very easy, okay, it is around slope. I brought it because I wanted you to, you know, understand about slope. Some people are completely ignoring coordinate geometry here, do not do that, okay, at least straight lines and triangles should be very clear to you, especially in terms of coordinate geometry, okay. Now, we will come to this question which says that in how many ways can 100 be written as a sum of two positive integer co-prime to each other. I hope you guys know the meaning of coprime. Coprime means if there are two numbers and they have HCF 1, they have only one HCF, that is 1, the highest common factor is 1 only, okay. So, two positive integers, say x and y, they have a sum 100 and they are co-prime. So, they will have nothing in common, okay. These two numbers will have just 1 as a common factor, nothing else. They are both positive integers, okay. In such questions, there is a trick, okay, that you have to use. If we will not be getting into the derivation, I will tell you the concept over here. If you have been given two numbers x plus y and their sum is given n, where n is a natural number, obviously it will be a positive number because coprime does not make sense for negative numbers. Then number of positive solutions such that x and y are coprime is Euler of n. Now, many of you might not be knowing Euler of n. Let me tell you what is Euler of n, okay. It has been explained over here. If you have a number n, first of all you have to do its prime factorization. You know, you all of you know how to do the prime factorization, right. So, do the prime factorization of a given number. Once you have the prime factorization, it looks like this, prime ki power something into other prime ki power something. So, Euler of n will be the number given into 1 minus 1 upon a into 1 minus 1 upon b, and if the number has more prime factors, you have to keep doing it, okay, where a and b are prime factors. There might be more than 2 prime factors in the prime factorization of the number given, okay. So, if you find out Euler of n, that gives you ordered solution. I will tell you what ordered solution is. If you have to find out unordered solution, you have to divide the Euler value that you are finding out by 2. Now, let me just show you how to do it, okay. There are two numbers, positive numbers that should have a sum 100 and they should be co-prime to each other. So, this is my n, right. I have to find out the Euler of n, that means Euler of 100, and to find out Euler value of some number, I have to do its prime factorization. So, 100 will be written as 2 square into 5 square. What are the prime factors in prime factorization of 100? 2 and 5 only. So, what will be the Euler value of 100? Euler value of a number n is the number into 1 minus 1 upon a into 1 minus 1 upon b and so on, so on, so on. You will keep putting the prime values that you are getting. Suppose you put 1200 here. So, obviously, you will be having 253 to the power something. So, then in that case, if 253 are the prime, you will increase one more bracket over here, 1 minus 1 upon third prime, okay. So if you have to find out the value of 100, Euler value of 100, it will be 100 into number into 1 minus 1 upon first prime factor. So first prime factor of 100 is 2, second prime factor 1 minus 1 upon 5. If you would have had more factors of a number, prime factors, you would have increased one more bracket and written 1 minus 1 upon the other prime, okay. But okay, this is what we have now. 1 minus 1 by 2 is half, 1 minus 1 by 5 is 4 by 5, 2 into 5 is 10, 0 cancels, we get 40. I hope that is clear. Now in this question, I told you that there are two special words over here, okay, if you remember, ordered and unordered. So if they have given you an equation, something like this, if they give you an equation in the question, it was simply given that there are two integers, they should have some 100. So suppose if 3 and 97, this is a pair of such numbers, right? I mean 3 and 97 are coprime, they have HCF1 and they have a some 100. So 397 also satisfied, while 97 comma 3 also satisfied, right? These are also two numbers having some 100. But in such questions where variables are not given or the equation is not given, suppose you would have been given in the question something like this, if x plus y equals to 100, if the question would have been like this, if x plus y equal to 100, then how many such coprime values, positive values of x comma y exist so that their sum is 100. In that case, x3 y97 would be a special pair, different pair, while x97 y3 would have been a different pair. They would have been counted as different pairs. But in this particular question, it was simply mentioned that there have to be two numbers. The moment two numbers have a sum 100 and they are coprime, it will be counted. So once you have counted 397, there is no need to count 97.3. So when you do not count the, I would say, reverse pair as well. When you do not count the reverse pair, it is called unordered, okay. Ordered does not matter. But in case the question would have mentioned that there are two integers x and y, x plus y positive integers that have a sum 100 and are coprime, in that case variables are mentioned. In that case, x3 y97 and x97 y3 matters, order matters. So that case when order matters, then we will call it ordered. In ordered, answer will be double of what you are getting as the Euler value, okay. So what do you see here? For unordered, value will be Euler of n by 2. So in such cases, you have to count the order as well, okay. So when you talk about this particular case, for unordered answers, you will have to divide the Euler value by 2. While if you are counting ordered pairs, okay, in that case you can simply give the answer, fine. So Euler of n gives you ordered solution. In this particular question, do we need ordered? In this particular question, do we need ordered solution? No. In this question, we need unordered. So unordered will be Euler of n by 2. That means your answer is 40, 40 by 2. So 20 will be our answer. But if I take you to this particular question, it says x plus y equal to 500, find the total number of natural solutions such that x and y are coprime. So there are two numbers, coprime, natural means positive, they have a sum 500. In this case, order matters. How? Suppose I have one pair 1 comma 499. These are two numbers having HCF1, so they are coprime. This is x, this is y. But there can be one more pair having x equal to 499 and y equal to 1. These are also two numbers having sum 500 and they are coprime, isn't it? So in this case, we will be counting ordered pairs. That means Euler value of n. Whatever Euler value of this number will come out, that will be my answer. But if this would not have been given, the question would have been like, find the total number of natural solutions such that x and y are two numbers which are coprime and have a sum of 500. Then in that case, we would have given unordered solution, Euler value would have been divided by 2. So let's do it over here. This is my number 500, do the prime factorization of 500. It will be 5 cube into 2 square, 125 into 4 is 500. So what are the primes that we are getting? 5 and 2. So Euler of 500 will be 500, 1 minus 1 upon first prime, that is 5, 1 minus 1 upon second prime, that is 2. What do you get? 500 into 1 minus 1 by 5 is 4 by 5, 1 minus 1 by 2 is half, 5 to your 10 gone, 50 into 4, 200. 200 is my answer because this is Euler value of number given gives you ordered pairs, and when variables are mentioned, order matters, okay. When variables are not given in this particular question, order does not matter. In this case, whatever Euler value is coming out, you will have to divide it by 2, that gives you unordered. So Euler value gives ordered, when variables are there, answer ordered answer, and if it simply says pairs, then you will have to answer unordered, divide Euler value by 2. Okay, this is very important. Okay, such type of questions can come. If you talk about this particular question, how many different possible natural values can n take such that n square minus 13n plus 50 is a perfect square? Okay, you want to make it a perfect square. Now, many of you will try to do something like this. Okay, so suppose you have n square minus 13n, okay, n square minus 13n plus 50. So, n square minus 13n plus 50. You want to make it a complete square. So, many of you will try to make it a n minus something ka square plus something something, right. If you do that, it will become complex. See how? N square is needed, so you will definitely write n, then minus of this n is needed, so n minus, you will obviously do 13 by 2 ka square, yes or no? In that case only it becomes something like this, a square, that means n square, minus 2ab, so minus 2 into n into 13 by 2, so then it becomes, right, minus 13, and then plus 13 by 2 square will be something which is extra over here, which will be generated. Okay, so minus 13 by 2, okay, because extra 13 by 2 square will be generated over here, that has to be cancelled with negative 13 by 2 square, and there was an extra 50 over here. What do you get? You get n minus 13 by 2 ka whole square, but here you get a very complex number. Okay, you cannot directly put values of n and check whether it is going to become a perfect square or not. So, in such cases what you have to do is, you know that this has to be made a perfect square. So, let us say that n square minus 13n plus 50 equal to some perfect square, x square. Okay. Now, try to complete the square. Okay, we will try to do it, but we will try to minimize fractions. So, how can we minimize fractions? I need 13n over here. So, can I write it like 2n minus 13 ka square? Just see. If I do 2n minus 13 ka square, I am going to get a 4n square. Then 2ab, that means I am going to get minus 52n. I am also going to get 169. Yes or no? If I just go ahead with n minus something ka square, I am going to get a fraction in the end, like I did in the previous step, but I do not want a fraction. So, in that case I multiplied a 2 with this n. Okay, so 2n minus 13 ka square is definitely giving me 4n square minus 52n plus 169. So, if this entire equation is multiplied by 4, okay, this entire equation is multiplied with 4. So, right hand side will also be multiplied with 4. What do you get? 4n square minus 52n minus 52n. 4 into 50 becomes 200 plus ka 200. So, plus 169 is here, that means I need to add another 31 and that should become 4x square. Yes or no? I hope that is clear. What else should we do here? Now, can we say that this is 2n minus 13 ka square? This entire part is 2n minus 13 ka square. Can this minus 4x square be brought here? And can this 31 be sent there and written as this, right? This is a square minus b square now. So, 2n minus 13 square, okay, minus 4x square. So, minus 4x square now can be written as 2x ka whole square, yes or no? So, it can now be written as 2x whole square, and that should be equal to minus 31. You have to transform it like this, okay. A square minus b square, so a minus b into a plus b, right, and that should be equal to minus 31. Now, there are two numbers being multiplied giving you a product minus 31. So, when is minus 31 possible? Minus 31 is a prime number, either you get minus 1 into 31 or you get 1 into minus 31. Now, do one thing. Obviously, these are the two values possible, right? Two values possible to give a product minus 31. So, in one of the solutions, this will be given equal to minus 1, this will be given equal to 31. So, let us do that. Say 2n minus 13 minus 2x is given equal to minus 1, and 2n minus 13 plus 2x is given equal to 31. If you add both of them, x cancels, what do you get? You get 4n minus 26, that is equal to 30. So, n will be equal to 56 by 4, that means 14. So, n will be 14. What did we need? How many different possible natural values can n take? So, one of the natural values that n can take is 14. In the same way, so 14 is one natural value of n. That happened when this was minus 1, this was 31. Okay. In the second case, we will use this value. Okay. So, we will keep everything else same. Why we will change these values. Okay. So, this one becomes 1, this one becomes minus 31. What happens? If you add both of these, you get these two cancel, 4n minus 26 equal to minus 30. So, 4n will be equal to minus 4, n will be equal to minus 1. Is minus 1 a natural number value, natural value n? No, it is not a natural value, it is negative value, so it will not be taken. So, that means there is only one such value that n can take, which is 14. If you put it here, it is going to give you a perfect square value. Okay. So, that is how you have to do this question. I hope that is clear. Otherwise, if you go through the previous method, you do hit and trials, you won't be able to do it. Okay. In similar way, you have this particular question, n square minus 6n plus 25. Now, see what is possible over here, n square minus 6n plus 25. This also has to be a perfect square. Okay. How can you make it a perfect square? Can you do n minus 3 square? Yes, because n square you will be getting minus 6n, you will get a plus extra 9. Okay. So, that plus extra 9 should be cancelled with a minus 9. Okay. Then only you will be getting this part, there is an extra 25 over here and there is x square over here. What do you get? You get n minus 3 square, okay. This x square comes here, minus x square, this plus 16, right, this plus 16 goes there, minus 16. So, a square minus b square, so a plus b into a minus b, that is equal to minus 16. Now, there are two numbers, they should be multiplied with each other to give minus 16, and we again have to find natural possible values of n. So, minus 16 will now be divided into a lot of cases. Okay. Minus 16 can be written as minus 1 into 16. Okay. Now, there is one logic over here, see, this is n minus 3 plus x. Okay. So, n is a natural value, so this will be a bigger value and we are adding something to it. Okay. So, minus 1 into 16 or 16 into minus 1, then minus 4 into 4 or 4 into minus 4, right, or minus 2 into 8 or 2 into minus 8, right. All of these cases are possible. See, here what do you get if you add both of them? If you add both of them, they will have to be added, right, because n minus 3 plus x, n minus 3 minus x, x will cancel. So, 2n minus 6 will be there, and 2n minus 6, you just have to take 2n minus 6 equal to what? The sum of these two, because you are adding both the values, yes or no, adding both the values. So, here it is going to give you what? Minus 15, sorry 15 in first case it should be equal to 15, second case it should be equal to, okay, this is same. Okay. So, minus 16 into 1, so minus 15 second case. Third case, minus 4 into 4, this is going to give you 0, the next case also is going to give you 0. Okay. So, these are two same cases basically. If you add these two, you get 6, if you add the another two, you get minus 6. So, now you can find out whichever values of n are you getting as a natural number. So, it is easy, isn't it? In this case, 2n will be equal to 15 plus 6, 21 by 2, n will be 21 by 2, which is not an integer value. Here again minus 11 by 2, here n will be equal to 3. So, in this case you will be getting an integer value. If you go ahead with 6 plus 6, right. So, this is giving you some plus 6. So, minus 6 plus 6, so n will be again 0, right, and this is minus 6 equal to minus 6, this is going to again give you a 0. So, there are how many values? It will be just two integer values of n in this case. Okay. One of them will be what? 6, n equal to 6 when 2n minus 6 is 6, and one will be n equal to 0 when 2n minus 6 is equal to minus 6. So, there will be two integer values. I hope you have got how to do such questions. Okay. The next question is find the number of non-negative integral solutions of this. So, this is also very important. Okay. Such questions can come. Non-negative means 0 is allowed, because 0 is not negative, right. 0 is allowed and all the numbers ahead of 0 are also allowed, but they should be integral means integer. Okay. So, 3 numbers having a sum 4, they should not be 0 more than that. Okay. So, you have to go through the concepts first. Okay. Whenever you have such equations where they ask you, non-negative integral solutions, positive integral solutions, if you have to find out number of non-negative integer solutions or integral solutions of x plus y plus z, and suppose you have r terms over here. Okay. You have x, y, z, and then 4, 5 terms over here. So, you will count their number, how many terms am I adding in the left hand side, that will be the value of r. So, r is the number of terms in the left hand side which are being added. n is the number on the right hand side, that is given on the right hand side. So, number of non-negative integral solutions is always n plus r minus 1 c r minus 1. So, this is something that you see in PNC, right, NCR, it is similar, okay. So, you have to apply the formula of NCR over here. Next, number of positive integer solutions of x plus y plus z till r terms. So, r is the number of terms being added on the left hand side, n is the number on the right hand side, n minus 1 c r minus 1 will be the number of positive integer solutions. What is the difference between non-negative and positive? In positive, 0 is not allowed, right. Third, number of integer solutions of x plus y plus z up till r terms equal to n is infinite. How? It says just integral. So, you can either have positive, negative, both values, right. So, suppose I just give you two terms x plus y equal to 5. You are allowed to have any two integer values for x and y, and you have to take out a sum 5. So, there can be infinite values, 8 minus 3, 7 minus 2 minus 1 and plus 6, 7 minus 2, 11 minus 6. You can take up numbers like 100 minus 95. There can be so many values of x and y that will give you a sum 5 if all integers are allowed. So, if all integers are allowed, plus minus both, then there are infinite such solutions of this equation, and there is a very simple logic to that I have explained. You can put any two values here, plus minus, and they should have a sum 5. Right. Number of real or real positive or real non-negative solutions of x plus y plus z up till r terms equal to n is infinite as well. Why? Because here there is a big word mentioned, that is real positive or real non-negative, okay, or real. Real means each type of number, positive, negative, decimal, fraction, everything. So, just imagine in how many ways can you write 5 as a sum of two numbers in which every value is allowed, because in real, in fact, decimals are allowed. So, say 4.1 plus 0.9, 4.2 plus 0.8, 4.3 plus 0.7, 4.5 plus 0.5. In fact, in real, negative are also allowed. So, maybe 6.5 minus 1.5. So, there are so many cases that are going to occur, okay, in case of real. So, that is why here infinite integral solutions are there. So, this is number of non-negative integral solutions of a plus b plus c equal to 4. What will be the value of r here? R will be 3 because there are 1, 2, 3 terms in the left hand side being added. What will be the value of n? N will be 4. So, non-negative integral solutions is n plus r minus 1 c r minus 1. N is 4, so 4 plus r is 3 minus 1 c r minus 1. So, that is 6 c2. The value of n c2 is n into n minus 1 by 2. So, what is n here? It is 6. 6 into 6 minus 1, that is 5 by 2. So, 30 by 2 is 15. That is your answer. Easy question, okay. Do not leave such questions in the exam. For positive integer solutions, you have to use this. Let us try a few more variations. Find the number of natural number solutions. If they tell you natural number solutions, 0 is not a natural number. So, that means non-negative is not the case. Only positive integer solutions are allowed, okay. That means 1 or more are allowed. So, those are completely positive integer solutions. So, yes, because first positive integer is 1. So, r will be 3, n will be 100. Positive integer solutions or integral solutions, okay, is n minus 1 c r minus 1. That means 100 minus 1 c, 3 terms are being added. So, 3 minus 1, that means 99 c2. Now, you can apply n into n minus 1 by 2 on this and find out the answer, okay. Third question, find the number of even non-negative integral solutions. You want even values, so all of them should be even. So, shouldn't a be something like 2x, shouldn't b be something like 2y? How many terms do we have in the left hand side from a till j? That means we have a total of 10 terms. That simply means r is equal to 10, yes or no? N, the number in the right hand side is basically 1000, but see, do not just take up the value and start applying, okay. First of all, you have to read whether there is some change that is going to happen in these variables. Number of even non-negative matlab non-negative means 0 is allowed. So, 0 is a non-negative even number, yes, so 0 is allowed, and only even values are allowed. So, can I write a as 2x, b as 2y, c as 2z, 2p, 2qr, something like this till 10 terms, right, 10 terms, that should be equal to 1000. What else? 2 can be taken common from each and every number. So, 2 times x plus y plus z up till 10 terms, okay, that should be equal to 1000. So, that means this x plus y plus z up till 10 terms should be equal to 2 divides 1000, we get 500. So, x, y, z up till 10 terms should be equal to 500. This is your n now, because see, now you have brought it to the most simplest form. Now x is going to be 0 or more, okay? Y can be 0 or more, because 2x, if you put x equal to 0, there is going to be 0. 0 is allowed because non-negative is allowed, even is allowed, and 2 is ensuring that each and every number is even. So now you can apply formula of non-negative integral solutions over here, okay? Because if you put x equal to 1, that is going to become 2. If you put x equal to 0, y is going to become 0. 0, 2, 4, such positive values, non-negative even values are allowed. So here now x equal to 0, 1, 2, 3, everything is allowed, because if you put x equal to 0, this becomes 0. If you put x equal to 1, this becomes 2. X equal to 2, this becomes 4. All even values will be there, even if you put x equal to 0, 1, 2, 3, 4, so on. 0, 1, 2, 3, 4 means non-negative integral solutions. So this becomes n. So n plus r, how many terms did we have? 10 minus 1 c r minus 1. You can find this out. 509 c 9. That's your answer. Okay. I hope you've understood the logic now. In this question, find the number of odd non-negative integral solutions of a plus b plus c equal to 99. Odd, non-negative. You are also allowing 0, okay? But odd non-negative, what does that mean? Any odd number, odd numbers start from 1, yes or no? Because you do not have minus 1 as an odd number, right? So here non-negative means negative are not allowed, right? So you have to write odd numbers. How can that be written? 2x plus 1, this first number a can be written as 2x plus 1, okay? B can be written as 2y plus 1, C can be written as 2z plus 1, and these three odd numbers should have a sum 99. I have ensured that these three are odd numbers, okay, and odd non-negative integral numbers. Now, is x equal to 0, y equal to 0, z equal to 0 allowed? Yes. Even if you put x equal to 0, the number here that is going to come, that will be 1. If you put y equal to 0, number will be 1. If you put z equal to 0, number will be 1. So that means x, y, z can have value 0 as well. So that means 2 times x plus y plus z. Here we get 1, 1, 1, 3. 3 goes that side, 99 minus 3 is 96. Okay. So x plus y plus z is equal to how much? It is going to become 48. Now what values can you put for x, y, z? 0 is allowed, more than 0 is allowed, that means non-negative integral solutions. So n plus r, what is r? 3 minus 1c r minus 1, that means 50c2. That's your answer. Okay. You just have to check out that do we need some sort of conversion here according to the variables allowed, and then you have to apply the formula either for positive integral solutions or non-negative. Find the number of odd natural solutions. Odd natural, that means obviously you are going to start with 1 or more, okay. So that means a, what values can a take? Can a take values 2x plus 1? Yes. Even if x is equal to 0, the minimum odd number that we are getting is 1, and 1 is odd natural number, yes or no? Similarly 2y plus 1, this b can be written as 2y plus 1, c as 2z plus 1, this should be equal to 149. Now 2 times x plus y plus z should be equal to 1113, 149 minus 3 is 146, x plus y plus z is 73. Is 0 allowed? X plus y plus z 0 allowed? Yes, because if you put x equal to 0, you are going to get 1 and you needed odd natural numbers. So x, y, z 0 are allowed, because even then they are becoming odd natural numbers. You can find out the non-negative integral solution of this, n plus r minus 1 c r minus 1. Okay. Let's talk about this. Find the number of integral solutions of x plus y plus z equals to 10 such that all the variables are greater than 2. We want to make all variables greater than 2. So we have to ensure that x should be greater than 2. An integer, which is an integer greater than 2, it is 3. So can I write 3 as 3 plus, x as 3 plus a. We have to ensure that y is greater than 2. So can I write it as 3 plus b, or can I write z as 3 plus c and then make the sum 10? Yes. Now even if you put a equals to 0, b equal to 0, c equal to 0, aren't you getting x greater than 2, y greater than 2, z greater than 2, even when you have a equal to 0, b equal to 0, c equal to 0, right? Yes or no? So that means 0 is allowed. So that means a plus b plus c, 3, 3, 3, 9, 10 minus 9 is 1. The a, b, c 0 are allowed, that means we have to find out non-negative integral solutions. So n is 1, n plus r is 3 minus 1c r minus 1, that means 3c2. That's your answer. Okay, easy question. In how many ways can 8 identical apples be divided among 3 sisters? There are 3 sisters, let them be A, B, C, and total number of apples that we are going to divide between them. They are identical apples, okay? All apples are same. So total number of apples should be 8. they have not given us any constraint that each sister should get 1 or more. If they give us something like this sister should get 1 or more, we will write it as 1 plus x. If this sister gets 2 or more, then 2 plus y. C has 3 or more, then 3 plus y, and then we will check out whether we can put x, y, z 0 or more. Okay? But here they have not given anything. That means any sister can get 0 as well, not less than 0 obviously, because apples cannot be less than 0, right? So that simply means n is this, r is 3, a, b, c can take value 0 as well. So n plus r minus 1 c r minus 1, that is your answer. Okay? They can write identical chocolates here, something like that. This is the question: in how many ways can A, B, C, D get at most 15 chocolates such that each get at least 2? Now A, B, C, D. So let me say that A, B, C, D at most 15. Now at most 15 means less than equal to 15. Yes or no? At most 15 means maximum 15 or less than that. Everyone should get more than at least 2. At least 2, that means this should get 2 or more. So can I write it as 2 plus x, this as 2 plus y, then this as 2 plus z, and this as 2 plus say k, okay, 2 plus k, less than equal to 15. So what do I get? X, y, z, k, that should be less than equal to what? 2, 2, 2, 2, 8, 15 minus 8 is 7. This is what I am getting. Now just check whether x, y, z, k can have value 0 or not. They can have value 0. Now they can have value 0, because even if x, y, z, k are 0, this sister, if x is 0, this sister is going to get 2. If x is 1, this sister is going to get 3. That means 2 and 2 or more is being ensured, right? But because it is less than equal to 7 here, that means we have to take separate cases. What if they get 7 chocolates in total? What if they get total 6 chocolates? So we will have multiple cases over here. X plus y plus z plus k should be 7. It should be equal to 6, 5, 4, 3, 2, 1, 0. So x, y, z, k, for each and every case x, y, z, k, you will find out what non-negative integral solutions. So for this, suppose for this, what will you get? N plus r minus 1 c r minus 1. So for this first part, the solution is this. So 7c, 7, 3, 10, 10, 9, 9c2. So this is going to become, the first part is going to become 9c2. What about the other next part? N plus r. So 6 plus 3, 6 plus, okay, 4. There are 4 things over here, right? So 7 plus 4 minus 1, c 4 minus 1. So this is going to become 10c3, okay? Sorry, 10c3. This is going to become 6 plus 4, 10, 10 minus 1, 9, 9cr minus 1. So 9c3. And similarly, it is going to go till this last one. What is this? N equal to 0. So 0 plus 4 minus 1, 3c3. So till 3c3. From 10c3 till 3c3, you have to find out the sum. That's your answer. Okay. That's it for today's session. These questions are very important. Okay. I hope you understood how to solve them, and do practice them. Okay. If you have any doubt, do ask. And in IPMAT 2025 or 24, there has been a question which was asked something like this. Okay. So go through that particular question. It was written something like a plus b plus c, sum is between 15 to 20, how many integral solutions are possible. So do try that question. Such questions have appeared in IPMAT, so that is the reason I did them. I hope you enjoyed the session. We'll meet in the next one. Okay. Try this question if you can. Okay. Even though I don't have a very good feeling that this will be asked in IPMAT, but still give it a try. Okay. Give it a try. IPMAT actually has no bar. Indore has a no bar of difficulty. Okay. So they can ask you even such type of questions. These two are homework. We'll meet again in the next session and try to touch 100 questions in the next session. Okay. Thank you so much.